Hello everyone, welcome back to our channel. So Shomu sir, what are we discussing today?
It's a basic concept on regular hexagon. So rather what I'll do is I'll just elaborate a little few things related to a regular hexagon that everybody should be aware of. So
Right.
let me just quickly draw one. Now, whenever we have a regular hexagon related question, there has to be something related to angles and stuff like that. I mean, it might be possible that you are aware of those derivations that comes out to be from the angles and stuff. But the basic property of a polygon is sum of exterior angles is always 360 degrees, right? So if you have a hexagon, so there are 6 exterior angles, sum is 360, and because it is regular, so each interior angle are equal, implying each exterior angle is also equal. So each exterior angle should be 360 by 6. So because there are 6 vertices, each vertex has one exterior angle. So each of the exterior angle should be 60 degrees.
60 degrees, right.
Implying each interior should be 120 degrees because total will be 180. So the
Correct,
idea
correct.
what, I mean, the basic idea that generates from this kind of thing is, so if I consider, let's say, let me draw this a little properly. Let's consider the prime diagonals. Then that would each of these prime diagonals will divide the hexagon into 2 equal parts, right? So essentially this 120 degree will also be divided into 60 degree and 60 degree. So in a regular hexagon, what happens is, just because of this idea, I mean, this is 60 degree, I mean, similarly here also you'll have a 60 degree. So leaving 60 degree here. So this is an equilateral triangle, right? So in a regular hexagon, you always form 6 equilateral triangles from the 3 prime diagonals. Prime diagonal is basically the one connecting the opposite vertices. Now, in this question, what are we looking for is ABCDEF is a regular hexagon with side 1 centimeter. So the side length is given to us. Any one of the side is 1 centimeter. The area of the square with AC as one of the sides. So if I consider, let's say A, B, C, D, E, F, or whatever, I'm not naming the rest of it. So we are considering the side length as this AC, right? This is what we are concerned about. So all we have to do is just figure out this length of AC, and that's it. So there are a lot of ways to do this. If you just focus on, let's say, this particular triangle here. So let me just name this. So let's say D. So if you're focusing on this ABD triangle out here, this is 60. This is obviously 90 degrees. So this is 30 degree, right? I mean, obviously 90 degree, even if you don't understand, I mean, this particular line should be dividing this into 2 equal halves, right? Just for the symmetry, you should be able to understand. And this being 60 degrees, so this should be 30 degrees, right? So that leaves 90 degree here. So this is a 30, 60, 90 triangle. And what do we know in a 30, 60, 90 triangle? That the sides opposite to these angles are in the ratio 1:√3:2, right? Now, in this ABD triangle, opposite to the 90 degree, the hypotenuse is the AB here, right? So this value is 1, isn't it? And since we are focusing on AC, again, just by symmetry, we should be able to understand AD is equal to DC, right? I mean, even if you don't understand, just think about this. I mean, this triangle and this triangle, ABD and ADC are the exact same triangle, right? Because of the regular thing out here. So if I can figure out AD by just doubling that, I'll figure out AC. So AD would be how much? AD is opposite to which particular angle? It's opposite to 60 degree, right? So we are looking for this one. So 2 is becoming halved. So √3 should be also half.
√3/2.
Yeah,
right.
so this should be the length of AD. And since we are looking for AC, which is twice of AD, so that should be twice of √3/2. So again, √3 out here. So the square that we are looking for has the side as √3, but we are looking for the area. So don't quickly mark it √3 as the answer. So the area will be AC square. So that would be √3 square or 3.
Okay. This was pretty straightforward. I mean, if you are able to visualize this properly.
So the only thing that, I mean, you just need to know that this is happening. I mean, you don't have to explicitly draw all the diagonals out here. And if you're aware of this property, all you have to do is just understand where is AC. That's all. If you just name this out, A, B, C, D, E, F, and all. So this is AC, right? Now, this being 120 degree, if you drop a perpendicular here, so this should be 60 degree. This should be 30 degree. You get the 30, 60, 90, and your job is done because opposite to 90, opposite to 60. This is √3/2. This should be √3/2, and that's it. So
Correct.
to understand the basic idea, I mean, this is all you have to do in this particular question.
Right, right.
So, I mean, just because it was such a straightforward question, so I thought about explaining a little bit more at the beginning. That's all.
Thank you. Thank you so much, sir, for this question. Thanks everyone for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.